All right, so we're going to check the conditions for inference for slope using the mucus data now. So the first thing we need to look at, conditions for inference for slope, are the treatments assigned at random. So this is for an experiment. Okay, for an experiment, you ask the question, are the treatments assigned at random? For observational studies, the conditions are random sample from a population of interest. So there's still the randomization condition. So what you need to know here is that there's still a randomization condition. If it's from an experiment, we assign the treatments at random, and if it's an observational study, was it from a random sample? So we already know it was stated that they were assigned at random from the other day. So this was stated in the problem. It's just notes from a couple days ago. All right, the linear model is appropriate. So the next condition you have to check is the linear model appropriate. So you have to check it with the residual plot. And the residual plot is, you're looking for no scatter, or no pattern. No pattern equals linear model good. Okay, this is a refresher. Linear model good if there is no pattern in the residual plot. So the residual plot from the mucus data, I think we actually made one in the notes, but it looked kind of like this. So really no pattern in the residual plot. And what would be bad? Well, it would be bad if there was little data over here and then it kind of spread out. So it was closer to the middle here and then spread out, or it did the opposite, farther away and then spread out. There's a curved pattern. There's clumps of points all in one little spot, and some of them are randomly out here. You just want it nice and spread out and pretty, dots are just really in a random place. You couldn't draw a scatter plot from this, a good relationship. So how do you get the residual plot for data? Well, in order to get the residual plot, which you'll have to do several times if it's not given, you'll have to enter your data in list 1 and list 2. So enter your data in list 1 and list 2. Then you're going to have to do stat calc 8, the linear regression, A plus BX. So you enter your data in list 1 and list 2, then you're going to have to calculate the regression line, and then you can go to stat plot, and you want it on, and you want graph 1, which is a scatter plot. Your X list needs to be list 1, wherever your X's are, and your Y list, to get your Y list, you want it to be the residuals. You want it to say resid there. That's how you graph your residual plot. To get that, you're going to hit second stat, so second stat, and then under the names, go down to residual. So second stat, go down to, or under names, go down to residual, and then just hit enter and it'll put that. So I do happen to have some data in here right now. It's not the right data, but I could go, let's see, second quit, I'm going to go stat calc 8, and I'll do list 1 and list 2, and all I need to do is calculate that. I don't need to write it down. But your residual data will not show up unless you do this stat calc 8. So you have to do the linear regression for your calculator to store the residual points. So now I go to second stat plot. I'm going to graph on. There's my first, that's your first graph type. It's a scatter plot. And then list 1, and then residual, and again to get there, second stat, and then I just go down here and then graph, and then you hit zoom 9. Now this is a totally different data. I'm going to clear that out of here. Now, does this residual plot, is this a good residual plot? I would say no. Here's why. There's clumps. There's little clumps of data. This is not very random. You know, it's got, you know, ignoring those points, it's got kind of a curve pattern here, but it's still got kind of a curve pattern, and there's definite clumps of points. There's more points below than there are above. It's not nice. It needs to be nice and scattered and very random.
I did get it.
This is not the same data you have. I already said at the beginning, this is totally different data. In fact, this data is actually for the last day of notes, this where we did nonlinear regression. So this is a residual plot for a relationship that I should not use a least squares regression line. Okay, so but in this case, I was just demonstrating how to get a residual plot. That was my purpose here. Okay, so now that's the first thing. Well, the second thing. So first we just checked to see were the treatments assigned at random or was it a random sample, and then we looked at the residual plot to see if linear model is appropriate, and then the variability of the residuals stays constant for all values of x. Well, guess how we check that? We check that with the residual plot too. Okay, how do we decide the variability of the residuals stay constant for all the values of x? Well, in other words, this is another good one to look at. So for this value of x here, you know, we've got, you know, a point close to the line and two others that are, one's kind of far away and the other's even farther away. Is that similar for all the values of x? For each value of x, is there a dot that's closer to the line, one that's pretty far away, and another, you know, it's all the same type of pattern. Okay? In other words, if there were a point here, if there were a point that, like above this value of x, if all the points were like blobbed right there, but all the others had some spread out, that you might question the variability of the residuals. Okay? So check with the residual plot. Again, the residual plot is the key here. For every value of x, it's got about the same spread above and below. So how about this one? The variability of the residuals. This is a different residual plot. The variability of the residuals is the same for all x's. So, you know, you've got this point, this residual is, well, it's that far. You can see how far away it is. Okay, this one, I mean, there's not two to compare here, so you just have to say, well, you know, this point and this point, they're about the same distance above and below, and then these points kind of match up. This point here causes me a little concern, because it's, you know, these are all kind of within this one little strip here, and this one kind of sticks out a little far. So this one, I might say, you know, the variabilities for this one is fairly constant. There's a little concern with this point here that it seems to be a very big residual. So this one is a little harder to check with the residual plot than is a linear model appropriate. Okay, and then finally, the residuals are approximately normally distributed. So this is the fourth condition we have to check, and we actually can check it with something different. We can check it with a normal probability plot of the residuals. And for this, how do I tell if the residuals are approximately normally distributed? The residuals are approximately normally distributed if the NPP is roughly linear. Really, the only new condition is that condition C. That's really the only new condition. Because when we did linear regression earlier in the year, we talked about a linear model is appropriate if there is no pattern in the residuals. We talked about having to assign things at random or random selection. And we also talked about the normal probability plot being roughly linear. So how would I check? Well, the normal probability plot, if you're going to graph that, second stat plot, turn your graph on. And the normal probability plot is type 6. So the normal probability plot, you're going to go to your stat plot, and it's graph type 6. And I'm going to select that, and it just says my data list, where are your X values? It's your X values, and make your data axis the x-axis and just graph it and zoom 9 it. And is that roughly linear?
Yeah.
It's roughly linear, okay? So if the normal probability plot is roughly linear, then the residuals are approximately normal.
So we want the data axis on
The what?
it. Can you show how you got that?
The data axis, X.
Yeah.
Data list, list 1. You want the X's. So 4 conditions to check. Is it normal, is it randomly, is it random sample or randomly assigned treatments? Is the linear model appropriate? In other words, is there no pattern in the residual plot? In that same residual plot, are the residuals all about the same distance from the middle? That's about the easiest way. Are all dots about same distance from the x-axis? Obviously, there is going to be a you're not looking for them to all be the same, but you're looking for like a range. You're not looking for a bunch of them to be really close to it and a few to be far away. And then look at the normal probability plot to see if it's roughly linear. Then, when you're doing your linear regression t-tests, then you can say that, yep, I can do this test now. So you've got 3 homework problems from page 677. And you've got a little bit of time to get started. So not only are you checking the conditions, you should be able to do the linear regression t-tests as well. So you'll have to maybe look at the last 2 sections of notes to refresh your memory.